I'm going to start us off here. My name is Malika Maruso. I'm the event coordinator for Synaptiq, and I'm going to give Tim, our speaker today, a brief introduction. So, Dr. Tim Oates is the co-founder and chief data scientist here at Synaptiq. He has over 20 years of experience in guiding organizations of all sizes and applying artificial intelligence and machine learning to business problems, and has guided over 100 clients to their data and future states with Synaptiq, both on the strategy side, even forward to the productionalization side. And he's earned a PhD in computer science from UMass Amherst with a focus on AI and machine learning, and has spent a year as a postdoctoral fellow at the MIT AI lab. And he's also a professor. So keep an eye out for Tim's other future events because he goes to speak and does a lot of cool research. So he's a very multifaceted co-founder and chief data scientist for us. So Tim, without further ado, I want to pass it over to you to say a couple words about Synaptiq and then get started.
Okay. Yep. Thanks, Malika. I appreciate it. So I'm glad everybody's here. I just have one slide to talk about Synaptiq. We are, actually my wife is asking me, what do you call yourselves? And I say, well, we're a data science consulting firm, but that means a lot of different things. Basically, we use AI and machine learning to look at hard, interesting problems in a lot of industries and turn those things into intelligent products. That can take a lot of different forms. So we do proof of concepts, we do productionalization, but as a company, we can go from the sort of ideation phase, doing AI and data strategy, all the way through to building products that you put into the hands of users. So a little bit about the company. My goal today is actually to talk about sort of business applications of AI and machine learning, and in particular, looking at a variety of different fields, kind of getting away from the standard, kind of like we're a tech company and we're going to do AI and machine learning, to think about how those tools can be used much more broadly. So the outline is essentially, I'll start out with a couple of slides on what are artificial intelligence and machine learning and data science. Those terms get thrown around a lot these days. And the terms have actually changed a little bit over the last 10 years, as I've seen them being used. Then I'll talk about some business applications of AI and machine learning. So I'll talk about predictive maintenance, improving bids and estimates, tagging data for better retrieval, evaluating and training the people who work for you, and writing proposals faster. So I will say that not all of these topics are created equally. I think one of them I've got one slide on, another topic I've got maybe 10 slides on. So, what I'm doing is really just trying to kind of lay out the art of the possible. So some of this is drawn from work that we've done as a company, and I'll, kind of talk about those a little bit and say, yeah, we sort of worked on that in a project. And then some of them are just, kind of thinking about what other people are doing in industry these days to use modern AI tools. And, no talk on AI can ignore large language models like ChatGPT. So somewhere in the middle of that, not at the end, but in the middle of all that, I'll talk a little bit about LLMs and how they work, and we'll actually see some examples of me using ChatGPT to attack some of these problems. So, and I would say that if you have questions, feel free to pop them in. I doubt that I'll see them because I'm in presentation mode, but I think Malika, feel free to interrupt me at any point if somebody's got a burning question at some point. So again, like start out, what are AI and ML and data science? And this Venn diagram kind of captures it. So artificial intelligence, AI, is the sort of overarching term. And back when I was in grad school, we were all doing AI, right? And so we were trying to figure out how do you implement aspects of the full range of human intelligence on a machine, so sensing, reasoning, acting, adapting through time. Now, within AI, we've got machine learning, and machine learning as defined. So Tom Mitchell, one of the founding fathers of the field of machine learning, said that it's the study of computer programs that get better at some task with experience. And so the idea is, what does experience look like? It can actually look like real experience in the world, and we'll talk about that in a minute, but it could just be, I got boatloads of data and I want to get better at a particular kind of task. Then within machine learning, there's this field of deep learning, and you've probably heard of neural networks, and deep learning is just taking neural networks that have lots and lots and lots of neurons, so lots of layers of neurons to solve problems. And the thing that's changed is that when I first came into AI, that was sort of the big field, and then machine learning was a subset of that, and deep learning didn't exist. And really, what's happened is this weird sort of explosion of deep learning. So, in the popular press, when people say they're doing AI, they really mean machine learning, and when they say machine learning, they really mean deep learning. So, basically, that deep learning bubble has grown, and it's like pushed out to the edges of machine learning and artificial intelligence. But, still involved in all that. We do statistics. A lot of machine learning is statistical in nature. So sometimes just computing averages of numbers is an important thing. Data engineering, just sort of moving these large volumes of data around efficiently and storing them in ways that it makes it easier to solve AI, machine learning, deep learning tasks is important. And sometimes you just like need a good visualization, right? Like looking at the data, a human looking at the data in ways that make sense to them is super important as well. And then so this term data science, I think, kind of spans all those things. It's all the AI and the ML, but it's bringing in the statistics and the data engineering and the visualization so that people can look at the data, packaging that all together so that you can actually extract value from data in, whatever corporate setting you've got. So really briefly, there are kind of three types of learning. That's a lie. There are lots of types of learning, but when you sort of do introduction to machine learning, you start out with these levels. And so there's supervised, unsupervised, and reinforcement learning. Turns out we'll talk mostly about supervised learning, but in supervised learning, you think about I've got a bunch of things and they're labeled by type. So the example there is I've got a bunch of email messages and I've sort of clicked a button that said these are important ones. And so I've labeled them. I've gone in and said, here are examples of important email messages. Here are examples of email messages. I might read them, but they're not as important as these crucial ones. And so in supervised learning, you get this set of things, and you've gone in and you said, here's the correct answer for each of the things. This is important. This is everything else. And a machine learning system will then try and say, all right, given that data, I want to be able to look at a new email message and tell whether it's important or not. Other examples could be suppose you've got a request for proposal. So you're in a business where you're bidding on a variety of kinds of things, and you've got historical data about, did my competitor down the street, who's a thorn in my side, did they bid on that proposal or not? I'd like to be able to learn to take a new proposal and figure out is my competitor going to bid because that'll influence the way I write my bid, for example. Or an actual use case that I talked to somebody about last week. There's a company that gathers audio. They actually have an ultrasound system. They listen to HVA systems running and they'll say, is the compressor on that thing bad or not? But again, it's sort of built by recording lots of audio and then knowing after the fact if the compressor was bad. Or for retention purposes, maybe I'd like to look at employee data. I'd like to sort of look at what they're doing and say, is this person a risk to quit in the next 6 months? And is there anything I can do about that? So supervised learning things, and then there's a sort of a correct answer for it. In unsupervised learning, you just get things, you don't get a correct answer. So you might get email messages, and I want to figure out what topics are there. Are there distinct topics so that I can organize the content and search through it more easily? Maybe I've got customer order history and I'm just trying to find groups of customers that have, similar buying patterns so that maybe I can focus on marketing to those individual cohorts better. Or maybe I've just got a bunch of vibration data from an escalator in a shopping mall and I'm looking for anomalies, right? Like, it seems like it's vibrating in a weird way. So maybe that thing is going to break down. And what I'd like to do is focus on maintenance tasks. Then the last kind of learning, which I'm not going to talk about at all today, but is just important to know it exists. There's this notion of reinforcement learning. So in reinforcement learning, like the example there is I'm a mouse in a maze and I start out in the maze and I'm trying to figure out should I turn left or turn right or move forward, and I get a reward at the end, right? So what I want to do is I want to find the food. And it turns out that reinforcement learning, when it hooked up with deep learning, led to some really amazing successes. So reinforcement learning was used to play the game Go at world class levels. And if you hadn't seen the movie about AlphaGo and the games that it played against Lee Sedol, who's pictured there, who is the best human player in the world. You should watch it because AlphaGo crushes him. Really sort of very interesting story. There's also reinforcement learning systems that can play Super Mario Brothers at expert levels. And then reinforcement learning, when you think about kind of self-driving cars, it's all about I'm taking visual input in and I'm trying to figure out should I steer left or steer right and apply the gas or the brake. And so again, like if I'm making decisions in the world, reinforcement learning is the way to go. Okay, so let's talk about a few of the use cases here and how you might apply these sort of data-driven methods for solving business problems. And so predictive maintenance is a big one. We've worked on cases like this at Synaptiq. And so you've got some machine that's running and you do preventative maintenance, which is, just like, oh, we routinely will go in and sort of do something to the machine to make sure that it stays in good working order. There's reactive maintenance on the right-hand side, which is like that thing, it smells like it's burning. It's making some crazy noise that everybody can hear. Let's go in there and actually do something to it. Predictive maintenance, on the other hand, is more again, trying to measure something. So I mentioned ultrasound before. Maybe I'm looking at the power signal, like how much power is that thing drawing? You can also use infrared to look at how much heat is being generated. And the idea is that you'd like to sort of run the machine and go, oh, you know what? I think something bad is happening. Let me get in and fix it before it becomes a problem and it actually breaks down, right? And then that machine is out of service. So here's an example that I've worked on in the past. We had this automated data acquisition system. It turns out it had these electromagnetic switches in them, and there were sensors, right, that would look and go, okay, like is the switch on or off? Turns out that we talked to a domain expert, and they said, well, that sort of good behavior on the left, it just goes from off to on, right? Boom, in just one transition. But when things start going wrong, it tries to change and it like clicks back and forth a little while and then it sort of, settles in. So we started looking at state transitions. And if you want to take a supervised learning approach in this case, which you can do, and is very common, you can see I've got three examples of clean transitions and three examples of bad transitions. So it's a very simplistic example, but it could just be here's some data we gathered from this machine when it was working smoothly. Here's some data we gathered from the machine, I don't know, a week before it broke. And I'm going to label those as good and bad. And I can hand that data set to a machine learning algorithm so that it can take a new example in and say, yep, that machine's in good working order, or nope, that machine is in bad working order. So very much a supervised learning approach. The other approach is to do an unsupervised method where you're doing anomaly detection. And in that case, I'm just going to gather a bunch of data. The machine seems like it's going along fine, right? Then what I do is I kind of get new data as time passes, and I say, does it look like it's similar to or different from the data that I gathered in a normal operating regime? And if it looks different, then you can kind of hand it off to a human expert and say, hey, take a look at this because something weird is going on with the machine. So some considerations, a lot of what I think about when I look at a project like this is, you got somebody who's been working for your company for 40 years and they've been around this machinery. Could they do it? Right? Could you send them in and they would say, yeah, show me the data. And oh, yeah, that thing's about to break. If that's the case, then I bet a machine could do it. And then you say, well, what information does that person use? What would they need? That's the kind of data that you need to get. So kind of think about, is it feasible to do that thing? For the ROI, you also have to think, is it worthwhile for me to do this? So how expensive is it for there to be downtime? And in the project that we were talking about before, it turns out that that system had tons of sensors on it, and the company was really, really didn't like to put new instrumentation in there. So they were really resistant to even letting us go in and wire up data storage so that we could kind of read what was going on and store it. They were generating tons of data. And so you had to think about how expensive is it going to be to get the sort of data from the control system out so that you can store it. And then, what's the effect of the increased uptime going to be? In that case, for that industry, downtime was horrible. That increased uptime was really important to them. So they invested heavily in it. Then you got to think about, okay, I want to do it, but should I do it anomaly detection? Should I do supervised learning? And this is a case where it might be just that if you had a dashboard that showed, here's the sensor data for the machine today, that a technician could walk by and go, yep, everything looks good, or nope, something's weird, we should think about it. So, it's not the case that in all the time we need to use machine learning or AI. Sometimes just showing the data in a good way can get you pretty far. Okay, so that is the first use case. Second use case is improving bids and estimates. So, as Malika said, I'm a academic, and so a lot of what I do, or I spend a fair amount of time trying to find money to pay graduate students, which means I'm, submitting RFPs. And, so those things can be really time consuming because it's a lot of effort put into looking at a request for proposals or a call for proposals, trying to understand what are they asking for. And actually, we'll see an example of doing something like that in a little bit later using a large language model. But we actually did a project like this at Synaptiq for a construction company where they had a team of people who would think, are we going to bid on this thing? How much are we going to bid? And then they would get into this mind game where they would go, okay, we think our competitor is going to bid on this thing. Do we think they're going to bid on it? And if they bid on it, how much are they going to bid on it? And they would think about all kinds of things like where is the job site relative to us versus them? Because if it's closer to them, it's going to be cheaper for them to get their machinery out there. Just it was incredibly complicated. But what they really wanted to know was two things, like that competitor, do we think they're going to bid on it? And if they bid on it, how much do we think they're going to bid? And so we used a supervised learning approach because we had all kinds of public data. We had the call for proposals, we had the text of it. We knew where the jobs were going to be located. And it turns out in that industry, um, especially betting for state and local government jobs, the bids were all made public after the winning bid was announced. So you had the historical competitor bids. They had all kinds of internal documents, people emailing back and forth about bid creation. They would go in after the fact and look and say, well, we won this, we lost that, what happened, what do we think, went on. They looked at projects after the fact. There were also internal documents about how they, what are the guidelines for the processes they follow, and just lots of internal knowledge about how that worked out. Then they had spreadsheets, right? So they had spreadsheets on historical bids that were won and lost, and spreadsheets that they used for creating bids where they would plug information in, and then historical project profitability. So the general approach that we took in that case, and this is sort of what you should do, is talk to experts. What information do they use? Again, coming back to this, even like predictive maintenance or bidding on, multi-million dollar contracts, really important to know what the experts are doing because they've got all this knowledge in their head and you ignore that at your peril, right? So using expert knowledge as you sort of build the models is super important. So how do they do it? What are the rules of thumb that they use? Then typically there's an effort to try and get the data, the relevant raw data into one location, like a data lake. So often we'll find that the data is just spread out all over the place and you got to kind of get it together, clean it up a little bit, extract relevant information, maybe enrich it as needed. So sometimes there are public data sources that you want to bring in. And then you can start thinking about building the predictive models, right? And so integrating knowledge from experts into the model design is important, right? So you should pay attention to that. This is more important. Sometimes we discover things that the experts find surprising, but it's very, again, you should pay attention to what they knew. No, you train the models to predict bidders and bids and include uncertainty measures, right? Because sometimes the models are very sure that that competitor is going to bid. Sometimes they're a little less certain about it, and then test very carefully. So in most situations like this, like you're not going to let a machine learning model control your bidding behavior, but you can use it to inform it and to make it better. So testing is super important. Okay, now switch gears again. We're going to talk about tagging data for better retrieval. So many industries have lots and lots of text data that they use for a variety of purposes. And often just putting a metadata tag on it. What kind of document is this? Like I've scanned it, but what kind of document is it? Can be very, very useful for just doing better keyword search, for example, which is still super common. So, And again, like the rule of thumb, which I use a lot, is if a human expert can do it pretty well, then it might be the case that a large language model can probably do it too. So in this case, we're going to think about mapping from text to tags or keywords. So we did a project with an immigration law firm. And what they would do is they had their clients who were people from other countries who are applying for high-tech jobs in the US just upload a ton of documents because the government wants a ton of documents before they make decisions about visa status and things like that. So they would take these PDFs and they would scan their driver's license and they'd write a cover letter and they'd fill out a government form and they'd upload it. And they would sort of, the client, who in this case was this person who is seeking to live in the United States to work in a tech industry, would just jam it all up into this portal. And so we built for them a system that would take that PDF and just figure out what kind of document it was, right? Like, boom, that's a driver's license. Boom, that's this government form number, 42J, for example. And so super useful for them because it allows their staff to not have to do that tedious task. We did lots of other stuff for them, but that's a very, very simple, kind of case. Also thinking about requests for proposals. What kind of job is it? Is it new commercial construction? Is it renovation? Is it an architectural design? If I've got inspection reports from a building site, who was the inspector? What was the date that the thing had? What issues were found? And we'll actually see some examples of this a little bit later. Okay, so I want to talk for a minute about large language models because I don't know how much people understand about the way they work. It's interesting. I actually gave a talk to a bunch of undergrads recently, and I said, "Who knows what a large language model is?" And like 5 out of 100 people raised their hand. And I said, "Who's used Chat GPT?" And 95 out of 100 people raised their hand. So large language models are just these computer programs that we can chat with, Chat GPT being the perfect example. And so what makes it a language model? The language model part of it just means I'm going to give you a part of a sentence and I want you to predict the next word. It's sort of as simple as that. So here we've got the cat. And if I ask you to give me the next word, you might go sat, right? Pretty common completion. Or the cat slept. Cats are sleeping all the time. Pretty common completion. Filibustered? Yeah, like I don't know. I can imagine saying the cat filibustered. I'm writing some story about cats who are running the government, right? But that's not as likely. And cactus, even like less likely. I could probably construct a sentence, but it's probably not going to be very good. So but what large language models do is they actually assign probabilities to these things. So they say, well, I've looked at a boatload of text and I think SAT is 10% likely to happen. Slapped is 8%. Filibuster and CACT is not impossible, but it's like 0.05% and 0.01%. So that's what a language model is going to do. So here's a very simple example that I coded myself. I got 2.2 million recipes from the web. There's like a data set out there that you can grab. It's got ingredients and instructions. And you can think about generating a recipe by choosing the next word based on just like the previous word that I saw or the previous two words or some number of words. And so in this case, I'm just going to look at the previous word. So I've got this little here start of an ingredient symbol, and it goes, okay, if I'm starting an ingredient, often an ingredient will start with a number like one. If I've got a number one in an ingredient, it might follow with a quantity, like a teaspoon. If I'm getting a teaspoon of something, I might be getting a teaspoon of chili. And if I've got chili, right, in a recipe, maybe it's powder. And if I've got powder, oh, that often like ends like end of sentence, right? So I've got beginning of sentence, end of sentence, and I'm just generating like that. And that's what language models do. You ask them a question, and then they go, okay, well, here's what I think is the next word, and the next word, and the next word. So, that works pretty well. I can do things like generating 1 cup of salsa, a fourth teaspoon of black pepper. Sometimes it doesn't work. So I've got 1 pint, which is actually 16 ounces, but it's like parentheses, oh, maybe it's 8 ounces softened, but I don't know what it is that's being softened. And then 1/2 cup applesauce or more for frying chicken stock, low sodium, right? So you can imagine that if you're just like looking at word like frying could be followed by chicken, chicken could be followed by stock, applesauce might be followed by more, right? So not seeing the full context can lead to bad generation. And so what the large part of language modeling is it's just that. All it is I've told you some stuff, please generate some text based on probabilities. But it's web scale data, my little recipe model had 10 million numbers that represented everything it knew about recipes, but ChatGPT has literally hundreds of billions of numbers that it uses to represent what the next word's going to be. And it has the ability to not just look at the one word to figure out what to say next. It looks at everything that you've told it or that it has generated. So like the miracle of large language models is it's like web scale data, and they can pay attention to everything in that workspace to generate the next bit of content. Last thing I want to say about LLMs is prompt engineering, which you may have heard of as a term, just means LLMs are very sensitive to how you phrase what you say. And we're going to see an example of that in the next 2 or 3 slides. So, I say, hey, LLM, I'd like you to do this thing. And even within a single LLM, very subtle changes in the way you phrase what you say to it can lead to big changes in the output. Across LLMs, it's even worse. But the reason is they just think left or right, like next word, next word, next word, next word. And so this prompt engineering is nothing more than scratching your head, thinking about how am I going to ask this LLM questions and interact with it to make it give me the answer I'm looking for in the right format. So here's a real simple example. So now we're going to go back to this tagging issue. So I don't know if people know this. Actually, I learned something today. So ChatGPT, now if you go to it, there's a paperclip icon. And so to the left of the place where you type your text, if you click on the paperclip icon, you can upload a document, and then you can start talking to the language model about that document and ask questions about it. What I learned today is that if you don't have Pro or whatever the premium one is, you can only ask so many questions. So I actually had to pay for that to finish my slides today, but that's fine. So here I uploaded a tax form. And so imagine you've got a bunch of, you're a tax attorney, you got a bunch of tax forms, people are uploading them. I uploaded a tax form, which I downloaded from the IRS website, and I said, what IRS tax form is this? Notice it gives me this very long answer. The document you uploaded is IRS form 990 for the year 2023, right? And it gives all this information about it. So I said, hey, all I want, just give me the form number. So what IRS tax form is this? Just give me the number. And it goes form 990, which is annoying because if I'm writing code to tag documents, I don't want the word form in there. So I said, what IRS tax form is this? Respond with just one token, which to the LLM means one word, essentially, which should be the form number. Actually, I said numner. so, but it figured it out, right? So it goes 990. Great. So there was like a tiny little example of prompt engineering. Here's another one. I went and grabbed a home inspection report. Maybe I want to tag those by the kinds of problems that were found. So I said, does this report mention problems with water damage? And it goes, yeah, and it gives me this long explanation of it, which is super, potentially interesting if I'm really trying to understand what's in the report. But then I said, okay, just like, does it mention problems with water damage? Just answer yes or no. It goes, yes, right? So now that I've got this template, does it mention problems with the foundation? Yes or no? Yes. Does the report mention problems with the roof? Just answer yes or no. No. So now I've got this LLM, which can just go and if I have some tags, I want to find all the houses that have no problems with the foundation and no problems with the roof, for example. I can just go query on those things. So, okay. One slide. I think I've got just two more test cases. So two more use cases. One is evaluating and training people. I have one slide on that. So let's just it sort of highlights an interesting use of supervised learning. So suppose you've got a bunch of salespeople. You might want to do the following thing: is I might want to look at a model that takes in their background information. What's their resume? What experience do they have as salespeople? What are their KPIs and their past performance with respect to those? And maybe what I want to include is call transcripts, right? Because I might want to assess I want to sort of look at how they're interacting with potential customers that they're on the phone with. So the good thing about modern machine learning systems is that I can take all that data and just dump it. And the machine learning systems are really good at handling diverse kinds of data. But then what do I want to do with it? So what I might want to do is say, well, do I think they're going to hit next quarter's sales quota? Right? I can learn a model based on that because I got a bunch of salespeople. I got all their data that are historical. I can then say these people made their quota, these people didn't make their quota. I could say where will they rank among salespeople in 6 months, right? So I could say is their trajectory up or down, for example, or if I've got a particular KPI, what's the value going to be next month, for example. Now, the interesting thing that you can do is notice I dumped in a bunch of data and I had that model learn based on that data to predict some measure of performance. What I can then do is I can ask the model, and there are pretty simple ways of doing this, of all the inputs for the salesperson, which were most important, right? Was it the fact that they either did or didn't get a particular kind of training? Was it the number of calls that they made? Did they have SDR support? And so you can go in and prospectively go, looks like they're not going to make their sales quota next next quarter. What if I gave them an SDR? You could just change the value of that feature and see, does the prediction go up or down, right? Like, would giving them SDR support help? If they increase the number of calls, would that get them to the point where they were able to make their quota, right? And so, because you've got this predictive model, which is taking descriptions about the salesperson, you can then start kind of doing what if, right? What if this salesperson had a different property for one of those features? Would they do better? Would they do worse? Then what you could do is you could say, well, it looks like if they had that training, which all of our top performing salespeople have got apparently, they would do better. Let's send them off to training. Or if they made 10% more calls, we think they would do a lot better. Let's like talk to that salesperson about how we can get them to, sort of manage their time so that they can make a larger number of calls, right? Okay. So the last topic that I want to go over is writing proposals faster. So the again, if you're in the business of writing document, you can think about this sort of very broadly, but I'm just going to think about it, concretely in terms of evaluating requests for proposals. So reading them can be hard. You can get a bunch of these things that you have to sort through. Do I think that this would be a good job for me to bid on? Does this look like a grant that my organization might be able to get? So just evaluating them is hard, but then writing them can be very, very painful. So the idea is that we can use LLMs to get you there faster. Now, I am not suggesting that you use an LLM to write your proposal for you. I will, in a minute, say that I think LLMs can do very useful work for you. They can actually help you generate things that are tedious, important from the standpoint of people looking at your company and being able to evaluate it. But I'm not suggesting that you let them write the core text. I personally try and resist using LLMs to do much or any of my writing. So, but what can they do for you? So an LLM can extract information from an RFP. And we'll see an example of that in just a minute. An LLM where you sort of push that button and say, hey, upload this RFP. It's like a smart person who's read it. They don't know a whole lot about your domain, but they can really understand the RFP, and you can just start asking them questions about it or ask the LLM questions about it. They can also create a skeleton of the proposal. So that's super useful because the LLM can kind of look at all the requirements, understand the order that they're supposed to occur in, and then just generate essentially an outline, right? Like, here's the thing you've got to write. You got to fill in all the pieces. They can also do things like write boilerplate from company documents. So if I got a bunch of documents that describe past projects I've done, the LLM can take that in, synthesize it, and write a nice, pithy, compelling piece about your experience in similar related areas. So, what I'd like to do is just go through one simple example. It's construction. Sorry, I was I was googling around for RFPs. Turns out Maryland, where I live, there is the Maryland Stadium Authority had a call out recently for construction management services for the Baltimore Convention Center. So they're going to do some capital improvements there. That thing is down in the middle of Baltimore. It looks like it needs maintenance. So hopefully they're going to do that thing. So I found this PDF. The PDF might have been, I don't know, 30, 35 pages. And so what I did was I went to Chat GPT and it goes, what can I help you with? And I clicked on the little paperclip icon and I just, uploaded that document. So that's all the preparation that I did. And then you can start asking questions like, when are proposals due? And it says this thing was due May 10th, 2024 at 1 p.m. local time, right? So that's useful. Didn't have to read a thing. It just goes, yep, here's the due date on that. Then you can say, how are proposals evaluated? Be brief. What I will say is if you just say, how are proposals evaluated? I think the first time I did this, it spewed out, I don't know, 3 pages of text. So it goes, there's technical criteria, financial criteria, and then there's an oral presentation, right? So, okay, look, if I make the short list, then I'm going to have to present my approach and that'll influence the final rankings. But, cost effectiveness of the financial proposal, and then like, do I demonstrate understanding of the project? What are my experience? What are my qualifications? All right. So, okay. So nothing surprising there, but it's nice to know that there's an oral presentation if it gets to that point. Then I can say, hey, can you create a skeleton response to this RFP based on what they require? And it goes fine. Below is a skeleton outline. The structure aligns with the RFP requirements and ensures compliance with its format. That's awesome. I make mistakes all the time in formatting, and fortunately, I got people who help me with that. But here's just a piece of it, right? And so it goes, okay, here's the technical proposal, title page, table of contents, executive summary, right? Brief summary of the firm's qualifications, stating exceptions to the terms if applicable. So there's a ton of content in here, but it goes, all right, there's a attachment A, attachment B, there's another attachment, there's a copy of the Maryland operating license. So there's all this stuff that has to go in there. So the interesting thing that you can do, and again, I'm going to encourage people to be a little bit careful about this, is you can say, okay, great. Here, you could write a prompt that goes, here's the RFP. I would like to construct an initial version of this section. And furthermore, here are a bunch of documents that my company has produced, right? So you've got the RFP and you've got the information about what has to go into the proposal. You say, I'd like to get a draft of this section, and you're going to point it to some documents. The LLM, then, if you're not, it's going to be hard to do this with Chat GPT, but there are other systems, and I can answer questions on that. We've built systems like this for people. It'll go, okay, if you've got the right code, you can say, let me go find the relevant sections of those documents and build an initial draft of a section, right? So, for example, brief summary of the firm's qualifications, it could just bang that out for you. Um, and so these LLMs can do this sort of ingest. Let me sit and chat with it for a while to see if it looks like it's relevant to me and my company and sort of the things that we want to try and do. Once I've figured out that I want to go, I can say, hey, LLM, can you generate a skeleton of this proposal? Then what I could do is I could hand pieces off to people in my company to write, and I can use the LLM in conjunction with some of my corporate documents, maybe past proposals, other kind of information that I've got to sort of bang out the boilerplate parts of it. Again, I would never, ever, ever submit text written by an LLM that a human hasn't looked at, because they can say things that would make you look very bad. But it could be the case that, um, it could just save a bunch of time, right? Instead of having this person spend a day collating a bunch of information or documents, let them work with an LLM for an hour and get it done. Okay. So some considerations there are the size of the team and the scale of the effort, right? So is it just one person kind of getting a head start on it? I'm just going to sit and kind of do a little bit of pre-work, or is it going to be a bunch of people who are going to work on it? How many RFPs are you going to try and process, and what kinds of documents are you going to use? So if it's just you and you're doing some evaluation and you want to get an outline, you can use Chat GPT for that. If you've got people that want to collaborate and you want to ingest these additional documents, or you want to scale this thing up, then you probably need a little bit more code wrapped around that to make it a feasible thing. And so again, we're going to use Chat GPT. If it's ad hoc interactions, you don't want to store results in a database, fine, go that way. If you've got a team of people that are interacting with RFPs and related documents, um, or if you want to kind of leverage past proposals to get your corporate voice in there, which some people find very important, then you might need to kind of push the boundary a little bit of what you can do just by like hitting a public facing website. Okay, so just a few final thoughts. Um, again, like these examples were not tech company examples. So The point I'm trying to make is that there are a wide variety of industries that have lots of use cases where AI might be able to significantly impact your business. That could be internal, you could make processes faster, more efficient, more effective. It could be externally facing, you could let people sort of access your data in interesting and intelligent ways. But we see both all the time. Um, the other thing is, I just, again, want to point out some of these things you can do entirely on your own. You can use Chat GPT as a proposal writing guide. There are other cases. So we've worked with a lot of companies that are not in tech industries, but there's a guy or a girl in there who's just really interested in AI and machine learning, and they tend to start skilling up on their own. And they will tackle problems like this. So that's an interesting approach because you have this internal capacity that's learning. They can often get very useful work done. I do think, though, that as you're learning on the job, you're just going to move a little bit more slowly. And it has been my experience that the the a very lonely person is the junior data scientist who is the only person who does data science at a company because they know there's a ton of potential out there, but what they really need is they need somebody who's been around the block a few times to bounce ideas off of. So that can work as well. I think outside experts, if you go, talk to somebody like us or other people who are in this space, it helps to kind of understand the art of the possible. A lot of what I do when I talk to clients is just like I really enjoy listening to what's their business, what are their problems, what data do they have, and then just start thinking about all the things that they might be able to do. So that's very useful when you've got people like me who have got gray beards and have been doing AI for 30 years. The other thing that I think outside experts can help with is just kind of scoping projects. So some companies are just all in, we're going to get AI, and they're going to dive in the deep end. Others are a little more skeptical and say, we'd like to do something small to start out just to kind of see how that works for us. And then, implementing a proof of concept or production system is something that other sort of, is a good if you don't have that skill internally, which again tends to be a little bit less common in non-tech companies. So that's it. That's the end of the presentation. Thank you. I hope you sort of at least again kind of see that there's a lot of room to run with AI and machine learning in non-tech industries and get some ideas that you might be able to use in your own company. I'd be happy to take questions. Malika, I might need help with that though.
That's okay. I can pull them up. So far, we don't have any questions, but Tim, thank you so much for that presentation. It was really interesting. Um, Folks who are still here, if you have any questions, I'd encourage you to take a few minutes to put them into that Q&A box or the chat. I'll monitor both because we've got about 15 minutes on the clock still left in our time here, so we're happy to stay and answer any questions that you have.
Maybe I answered all their questions.
You very well might have.
Right.
That's all right. Well, I do want to point anyone who's still here. There is an email address at the bottom. I will put it in the chat as well. Oh, it looks like we do have a question, so I'll get to that in just a minute. If anyone isn't comfortable asking questions live here today, you can email us at asktim@synaptic.ai and submit questions, even not today, tomorrow, the next day, whenever you think of them, and we will be happy to get back to you to answer those questions. But it looks like we do have an anonymous question here. So, Tim, great presentation. Thank you, says the attendee. Any chance you could highlight any particularly successful AI engagements you've had, and perhaps an example of one that did not work out as well?
Um, uh, sure. I'll mention one that I think was highly successful. We actually engaged with a company that is in coral reef restoration. And so what that company does is they grow coral. They get these, they basically, you can chip a piece of a coral off, and then if you handle it carefully, it will grow into a more robust piece. and then you can go and replant it. And so the idea is that you're trying to sort of farm these corals in kind of, on land in these big tanks and then plant them out in the wild. And you're trying to do that in a way such that they'll survive when they get planted out. They had lots of very interesting problems. The main one was tracking the health of the coral, right? They're growing in these giant tanks on these little plugs. So they want to track the health of them, and they need to do all kinds of maintenance, like cleaning the tank as they get really dirty. And so they had a system that they were using to try and image the coral, but we came in, got an outside contractor who was really good to help us with the imaging side of it, the kind of hardware piece of it. And then we developed a lot of machine learning models to answer lots of questions about, does this tank need cleaning? What's the health of the coral? How are they doing? Because the thing that they really care about is they have what they call this sort of I think they called it a ladder, but they would expose the coral to different temperatures, different flow rates, different qualities of water, just to kind of get them used to what was going to happen to them in the wild. So that was, I think, a super successful kind of fun project. Unfortunately, we never got to go on site. They're in the Bahamas, and nobody ever got to go. That's the disadvantage of being a fully distributed company. Um, a project that didn't go well. I mean, I have one in mind. I don't want to talk about it, but but um, I, you know, I would say that projects, if they run into problems, tend to be on the data side. So sometimes you'll go to a company and the people are saying, we want you to do this thing and we've got this data. And we all go, yeah, we can do that thing with that data. And then when you get into the data, it's just not the quality that you're looking for. So um, that project was actually the one I'm thinking of that I don't want to talk about. It was in the retail space, um, and it turns out that it was sort of poorly scoped, and the data wasn't really there to support it. And so, I think one thing that we've learned by doing projects like this over the years is that we really hammer on, okay, like you got this data, but let's see it. Like let's take a look at that thing really to kind of make sure that it's feasible, and nobody's wasting their time, right, on the project. Hopefully that answers the question.
I think so. Feel free to ask a follow-up, whoever asked that question as well, if not, or email us for more information because we'd be happy to chat with you a bit more. Thank you for that answer, Tim. I think that was very comprehensive, and I completely agree after hearing about that one. Um, does anyone else have any questions? Please feel free, put them in the Q&A or the chat. I'm monitoring both. Oh, looks like we got another one. Let's see. Yes, okay, it looks like that attendee did get their question answered, so that's
Okay,
great.
that's good.
That is about data quality, which I think we all agree that's true.
Yeah.
We'll wait another minute, but again, please feel free to email us your questions as well. Don't feel like this is the only time you can reach us. And please stay tuned. We will be running more webinars in the future, so please keep an eye out for your inbox for invitations to those if you're interested.